Welcome to your daily dose of statistics. I'm Professor Charlie Collins. Today we're going to be continuing our discussion of descriptive statistics. And specifically, we're going to continue our series of discussions of lectures on central tendency, variance, dispersion, and the normal curve. This second lecture is on variance and dispersion. So we'll be spending our time talking about measures of dispersion or distribution. And specifically, these are range, standard deviation, and variance. So through this lecture, we'll be talking about range, and we'll be talking about standard deviation and variance. So measures of dispersion, what they do is they measure the diversity, variety, spread, consistency, or distribution of scores, right? So this is all another way, these are all synonyms, right? It measures the variety of scores within a distribution of scores. There's several ways to do this, right? And we'll go over these in a few minutes. The importance of dispersion, why would you think it would be important to understand the diversity of something, right? Diversity can be a fairly important thing. Well, let's say we are a high public official and it's our job to appoint a judge. I think judges are elected, but let's say there's a special circumstance where we have to actually appoint a judge. And we have Judge A here versus Judge B, right? And what we find is that on average, both judges sentence people for let's say a misdemeanor crime to 245 days in jail, right? That's probably a lot, but you know, we're tough on crime, right? So we find out that on average, they sentence people to roughly 245 days for misdemeanor crimes. However, we find that for Judge A, her dispersion is 100 days, right? So she has a huge variety, a fairly large variety in her sentencing. Whereas Judge B's dispersion is 20 days, right? So Judge A, while her average is 245 days, some people get sentenced to much longer than that, and some people get sentenced to much shorter than that. Whereas Judge B, his sentencing isn't quite as distributed. It's not quite as long as 245 days, and at the low end, it's not quite as low, right? So he's a little more consistent in his sentencing, is what that comes out to, right? And so again, it's important to understand distribution or dispersion because it's important to understand the diversity of those various of things such as this, right? And there's ways to calculate this. First, let's discuss range. Range is the distance between the highest and the lowest score. So R in range is represented by the big letter R. So it's the high score minus the low score, and that is your range. And so let's take Judge A here, and let's look at her previous 5 sentences. She's sentenced somebody to 365 days, 730 days, 540 days, 30 days, and 60 days. So what we're going to do here is we're going to take the highest score, 730 days, and subtract that from the lowest score, which is 30 days. And so what we do is you see the range of 700 here, right? So you have 730 minus 30. That is a range of 700. Now, there's clear issues with using only 2 scores, right? If you have extreme outliers, for example, that will make your range much longer or much wider. There's another way to do that that is a little more accurate and more useful, and that is to calculate standard deviation and variance. Now, the standard deviation is the average distance of scores from the mean. So what this does, the nice thing about standard deviation is that standard deviation and variance both use all the scores in a set of scores, whereas something like range only uses 2 scores in a set of scores. So this gives us a little more accuracy, and it's a little more. It's a slight more sensitive measure than range is. And so here's our equations, right? And so it's important to note the difference between the population and the sample. They're the same basic equations, but for both variance and standard deviation, the samples in the denominator are the sample size minus 1, right? And that is because we assume that sample sizes aren't quite as evenly distributed. And we assume samples vary a little bit more than the population does. So minusing that 1 increases the variance just a little bit. The larger sample size we have, the less sensitive that will be. And so throughout the rest of this, I will be using the population calculations, or the population equations. So just keep that in mind. If you have a sample, use the sample equations instead. So we'll go over the 5 calculating standard deviation and then interpretation. So let's start with the 5 steps in calculating standard deviation. So first, what we need to do is compute the deviation scores. Now the deviation scores are the individual score minus the mean. Then we need to square those deviation scores. Then we need to sum those squared deviation scores, compute the variance, and then compute the standard deviation. Now again, as you notice, the variance and standard deviation are fairly close, very close equations here. The difference is that the standard deviation, you take the square root of the final score, whereas the variance, you just keep the variance, you don't square it. Or take the square, I should say. So let's just run through this process real quick. So let's say that I have a group of friends and they all went to a beer festival. And I'm interested in knowing the variety of beers that they have tried. Right? So I'm interested in knowing the dispersion of their, or the diversity of beers that they tried at the beer festival. And so what I do is I ask them, what are the varieties of beers you tried? What are the different types you've tried? And they all gave me their numbers. And so what I want to do from that is I want to calculate the variance and the standard deviation based on this information. So first question is, how do I do that? Well, we have to go through step 1. Step 1 is you take the score. So in the first case of Mr. Blonde tried 21 different types of beers. And we take that 21 and we minus the mean, right? And so I pre-calculated this. The mean for all of these is 25. And you go through the whole process with that, right? So you have to do it for every single case. So I've done that for all cases. Then you go to step 2 and you square those deviation scores. So step 1 is called the deviation scores, right? Because they deviate from the mean. Step 2 is the squared deviation scores. And you square those because if you don't square them, you'll end up with a 0 in this next step. Then you have to compute the sum of squares. So you sum all of those deviation scores. And the sum of squares is represented by this little SS down here. So you sum all of those deviation scores. So as you can see, the little arrows point to where they came from. And we end up, our sum of squares ends up with 782. Now that's not the final of our calculations here. We still have a couple more steps. Step 4 is we have to compute the variance, right? So what we do is we take those sums of squares, then we divide those by 7, which is our sample size. And we end up with a number of 111.743, right? So we take our sums of squares, divide that by our sample size, and that's our variance, right? Then we do one more step and we compute the standard deviation simply by taking the square root of our variance. And we end up with a standard deviation of 10.56. So what that's telling us is, on average, away from the mean, there was on average, people tasted a variety of roughly 10 to 11 beers difference than the mean, right? So it shows the variety of different beers that were tried in this context. So let's interpret variance and standard deviation in another way. And so what I want to do is I want to talk about, let's say I'm interested in the variety of illicit substances used at festivals. And so I'm interested in knowing, do people engage in a wider variety of illicit substance use at Burning Man or at Comic-Con, right? Say I'm a person and I'm interested in going to a new type of festival, and I'm not sure which to go to, and say I want to stay away from illicit substances as much as possible. And so we have our Burning Man here, and we have our Comic-Con. So what I find is that Burning Man, let's say Burning Man has a standard deviation of 4.5, Comic-Con has 1.2. So what is this telling us? I'll give you a second to think about that. So what this is telling us is that there's a greater variety of substance use among people who attend Burning Man compared to those who attend Comic-Con, right? But this, again, this variation, the standard deviation, doesn't tell us the average. There could be more substance use at Comic-Con, but at Burning Man they're using a wider variety of different substances, right? So that's another way to think about the use of standard deviation and variance. So that's standard deviation and variance, and that is our talk on distribution. And so that concludes the second piece of our descriptive statistics, or slightly more complex descriptive statistics. And you're almost through with this descriptive statistics piece. We'll move on to inferential statistics next. And that is your daily dose of statistics.